Welcome to another episode of Space News Astronomy Today. I'm your host, Abigail, and today's topic is going to cover the collapse of the Arecibo telescope. Starting with some background, the Arecibo Observatory, which was founded by Cornell University professor William E. Gordon, is the site of the telescope and was intended for radar studies of the Earth's ionosphere. The Arecibo telescope was the world's largest radio telescope, located just 16 kilometers outside of the town of Arecibo in Puerto Rico. It stood at 305 meters in diameter with a 265 radius of curvature and a 900-ton receiving platform. Constructed in 1963, the Arecibo was the communication site for astronomers to send and receive interstellar radio messages. One purpose for these interstellar radio messages was in case extraterrestrials potentially heard the transmitted frequencies. Additionally, with the telescope being the most powerful radar at the time, astronomers utilized the Arecibo to observe planets, asteroids, and the ionosphere. Some notable discoveries made by this telescope include finding the first exoplanets, prebiotic molecules in distant galaxies, and the first millisecond pulsar. In 1992, the Arecibo was also the first observatory to locate planets beyond the Earth's solar system. Due to these incredible discoveries, the Arecibo telescope held a pretty significant amount of modern and historical importance in the field of astronomy. Pretty neat, huh? Unfortunately, tragedy soon befell upon this astronomical gem when the telescope collapsed. It all started on the early Monday morning of August 10th, 2020, when one of the telescope's supporting cables snapped. More specifically, the auxiliary metal cable became loose from the socket it was attached to atop one of its three supporting platforms. This snap caused major damage to the telescope, and it ripped a 30-meter-long gash in the giant radio dish. The gash was investigated by engineers of the University of Central Florida, led by Arecibo director Francisco Cordova, and had been shut down in order for them to assess the damage. Unfortunately, things were not looking up for the telescope as time went on, and engineers were struggling to figure out the best method of repair for the telescope. On November 6, 2020, further damage was caused to the telescope as a second main cable failed. This time around, the cable snapped and also fell on top of Arecibo's giant dish, which caused further damage to other supporting cables nearby. From this second cable snap, the engineers predicted that another cable failure would cause the entire telescope to totally collapse. Additionally, engineers agreed that attempting to repair the damages caused to the telescope would be unsafe. As a result, the National Science Foundation, or NSF for short, who oversee the Arecibo, decided that there was no safe way to restore the observatory and scheduled for a controlled decommissioning of the Arecibo to avoid a catastrophic collapse. Then, just 2 weeks after the NFS made this announcement, the single-dish radio telescope collapsed on December 1st, 2020. The unfortunate collapse of the Arecibo telescope has several implications about the future directions of the field of astronomy. First, one of the Arecibo's major contributions to the field of astronomy was its incredible communication site for interstellar radio messages. In the wake of its collapse, the radio astronomy community will have to investigate the mechanisms that the Arecibo used to make this communication a success and explore ways to replace them using instruments they currently have. Secondly, the massive size of the Arecibo's dish to collect radio waves provided astronomers with the ability to see very faint objects and phenomena. Thus, the loss of such an incredible instrument will make it difficult for astronomers to collect similar data. Furthermore, the Arecibo was such an asset to the field of astronomy because of its incredible ability to detect pulsars. Pulsars are known as neutron stars that spin rapidly. As these pulsars rotate, they sweep beams of radio waves around in space, which can be detected back on Earth. Arecibo's large dish size made it possible to spot fickle light of pulsars and collect enough radio waves to be used for analysis in a matter of minutes. With that said, the loss of the Arecibo poses a challenge for smaller telescopes to do the same thing, and that it will require at least several hours to observe and collect enough radio waves for data analysis. The Arecibo's collapse will also impose future challenges on the field of astronomy due to its ability to transmit radio waves. To elaborate, the Arecibo was able to bounce radio waves off of atmospheric gases, asteroids, and planets. These reflected signals then provided information regarding the target's motion, shape, and size. Unfortunately, many of the radio astronomy telescopes today cannot do this as they do not have radio transmitters like the Arecibo did. Thank you for tuning in to this episode of Space News Astronomy Today, and I hope to see you next time.